Good morning or good afternoon, everybody from Dublin, Ireland. Thanks for joining us. I want to talk a little bit about facades today, and very much the energy efficiency of them and how to optimize them, particularly in early stages of the design, using Fenestra Pro and understanding facades and the effects that they have on building performance, etc. I'm going to touch on a few things. Want to keep it quite tight today. I'm going to just talk about, a quick bio, just to really touch on what Harry already introed us into. Talk about Fenestra Pro and our couple of different products, our core product being Fenestra Premium that we're going to talk about. A quick overview of the product itself, and then we're going to come back and just talk about the facade and the different considerations around the early stages of the design with regards to daylighting, solar heat gains, thermal performance, heat loss, etc. Then we'll jump in and dive in a little bit deeper into Fenestra Pro Premium, looking at the different types of modeling that is supported, the conceptual massing, the detailed modeling, and how we can very much drive the model and the facade design through Fenestra Pro and get a really good understanding of the implications of your design decisions from an early stage. We'll touch on some of the differences between Fenestra Pro and Insight, for example, and look at an overall workflow from conceptual stages using maybe Format or Revit into Revit, using Fenestra Pro to look at the glazing considerations and the facade design, and how Insight 360 can be leveraged within that then to get a EUI or an energy cost as such for the building performance. And any questions as we go, please drop them in the chat box, and I think Harry's going to circle back towards the end and we can talk about a couple of those. Just to go back on a quick intro, I'm an architect by profession. I'm one of the founders of Fenestra Pro, and myself and my co-founder Dave, we are both architects. We had a very early, we had a practice here in Dublin for a number of years. A lot of it was spent in our own respective specialisms. So my own in environmental design, Dave's in facade engineering. And I guess it was through our own practice and experience that we felt like, or very much identified, the requirement that architects need to design buildings better. Now, I'm not just talking about better buildings, but I'm talking about workflows as well. For years, architects have been very much relinquishing control over the environmental conditioning to engineers or specialists. And that led to a couple of things. It led to maybe poorer buildings, but also poorer workflows. And that was our initial belief in terms of what we were trying to do with Fenestra Pro. So we very much recognize the requirement for a software or a tool for architects to design energy efficient buildings and building facades that could achieve the kind of performances that we wanted to achieve, or meet the building regulations or codes that we wanted to comply with, without compromising the aesthetic design of the facade, and very much allowing the designer maintain control from an early point in the process. So with Fenestra Pro Premium, our solution has allowed some of our existing customers and clients to date design buildings quicker, more cost effectively, earlier in the design process. But as designers ourselves, it was really essential to us that we also allow architects to maintain control over the aesthetic from an early point in the process, and very much understand the implications of our design decisions. Because Fenestra Pro is operated from within the Revit platform, it can also show us very dynamically and in real time the effect that performance has on the aesthetic design, and vice versa, the effect that the aesthetic design has on the performance, in a very dynamic and ongoing way as you're building up your model, as opposed to exporting to a third-party platform, doing something over here, coming back to Revit, changing it over there, and this kind of inefficient workflow. So that, I suppose, has a couple of benefits. First of all, there was a significant reduction in time and costs. The ability to maintain aesthetic control from an early point in the process, and the ability to review compliance, particularly around the thermal performance aspects of the envelope and of the facade. And all of these things just give us the ability to, first of all, design better performing buildings, but also streamline our workflows and very much eliminate late stage rework and redesign, which, as we all know as designers, is frustrating, costly, kind of annoying, puts a massive workload on late. And if you think of the BIM methodology and the McLeamy curve, it's very much against what we're trying to do with building information modeling, where we want to make decisions early where they will have the greatest impact on the performance with the least costly or the most efficiency. So that's Fenestra Pro Premium that we're going to focus on today. We also have Fenestra Pro Target, which is a very lightweight, early, on-ramp, let's say, to premium, and it's just looking at one very small aspect of it, being the glass-to-wall ratio aspect of Fenestra Pro. Very much a conceptual design tool that looks at glass-to-wall ratio, and it's available on the Autodesk App Store at quite a low cost, and then you can upgrade to Fenestra Pro Premium. We've also got Fenestra Pro Link, which is in beta stage at the moment, which is much more allowing users to access live manufacturers' data on the cloud, and a much more intuitive way to search, import it, create it, filter it, against different considerations like solar heat gain coefficient versus location, or U value versus cost, and then import it into Revit and assign it to particular families or glazing elements or opaque wall elements, etc. For the moment, though, we'll focus on premium and looking at some of those key features and across the different stages of the building design. So conceptual design, we can look at glass to wall ratio for the building. We can look at the impacts of facade design on the energy performance. And if I have 80% glass to the southern facade, what does that mean to the overall building? We can look at shading design, for example, and the effects of that. And then into the later stages, we can start automatically generating glazing solutions, be they window penetrations or curtain wall elements to the model based on a performance requirement. So if I have a limit to my solar heat gains internally, how much glazing will that take? But I might want to make some design decisions around that. So Fenestra Pro will start automating that process and very much check compliance of the thermal values against codes throughout the process. We can, as an ongoing, at any point in that process, comparatively analyze between alternative designs or design options. We can look at the effects of glass to wall ratio on codes and material selection, and what will that do to my energy performance of my building. So let's jump into Fenestra Pro and give just a quick overview really on the navigation for starters. So it is an add-in, as I said, to Revit, and as such lives in the add-in ribbon. But unlike a lot of add-ins, there's quite a lot going on behind that button. So in its simplest sense, I suppose Fenestra Pro is a dashboard with some outline values that populate reading the model as we go. So as I change, if I deleted that curtain wall assembly, my percentage glazing will change. If I change values to thermal performance, my thermal performance values will change. So it's very dynamic and very in real time. And then as I select different facades, it updates based on my selection, which I'll talk about now in a second. Our performance manager is very much driven by code and elemental performance of different parts of the building, the floors, the roof, the opaque walls, the glazing, etc., and the effects that all of those the performances of all of those elements have on my glass to wall ratio, based on either codes or otherwise. And we can see where things are non-compliant or compliant. Again, I'll go into that in a little bit more detail in a second. Our facade manager drills in a little bit further. So I have nothing selected yet, and we see it's blank. But as I start populating that, be it through a tree or by selecting on the model, I can see things drop in and populate my facade manager and update my dashboards. From there, then I can start affecting change to the types of glazing or the quantity of glass, etc. We also have some outputs being charting, glass to wall ratio, solar loads internally. Again, this is based on my selection, but if I deselect this facade, we're looking at an overall building. So glass to wall ratio, solar load, daylight performance, and some document changes and guidance notes down here. Obviously, there's quite a lot of real estate being taken up by that, so I could, you know, pop out my my charts and leave them over here and have my dashboard over here. So there's lots of different ways that we can use Fenestra Pro and integrate it very efficiently and in a very streamlined manner into our workflow. You know, this is a detail model. If we look at a conceptual mass from Format or you know, the earlier stages of Revit, we'll see some slight differences on our facade manager. We'll see different ways of managing these facades, and again, I'm going to touch on that a little bit. Down here we have pretty much a toolbar showing, you know, we can highlight our building manager for the different types of building, and therefore you know, orientation, and therefore different radius of heat gains per orientation, quite high to the south, quite low to the north. This is based on any location and any orientation around the globe, and the different types of building, the use of it throughout the day, throughout the year. So all of those things very much drive the calculation methodology, and you know, lead you to, I suppose, selecting or making the most informed design decisions. Some basic options and configuration settings. Our charting, which we touched on. We're working on a Forge viewer, which I'll get back to towards the back end of the presentation of the webinar today, and a snapshot button where we can export to Excel at any point in the process. And again, I'll touch on that as we go today. So if we want to talk about facades for a second, let me come back to Fenestra Pro in a second. If we take a typical office building, and the breakout of the differing uses of that office building, we can see that heat loss through the walls or through the window, you know, or through the facade, as we might say, accounts for some 8%. Lighting through the facade, just under 20%. With regards to artificial lighting and the requirement, or sorry, natural daylighting and the requirement for artificial lighting. And then we have 26% taken up by heating and cooling loads to cool the space and you know, air conditioning, mechanical ventilation, cooling, all that sort of stuff, you know. So on a typical building, and this is by no means every building, by, you know, obviously, but a typical building, we could say that there's some 53% or in excess of half of that building's energy is directly influenced by the facade design. The geometry of the glazing, the properties of the glass, etc. So if I take a more macro level and I take the global operational energy use around the world, we can see, you know, we know that the built environment accounts for approximately 39% of our operational energy. If we're saying approximately half of that is taken up by the facade, we could deduce, I suppose, in a very kind of roundabout way, that about 20% of our operational energy use globally is directly influenced by the facade. That's something in the region of 9 billion tons of CO2 equivalent. Okay, so it may not be that, you know, that might be a worst case scenario, but even if we take that back quite conservatively and talk about 5 or 6 billion tons of CO2, I mean, that's a lot. So there's a lot we can do about that with regards to the performance of the building, and design buildings better and make some earlier decisions at driving towards a better performing building. And one of the best ways we can do that is around the passive design elements of the facade. So I'm talking particularly around the thermal, the solar heat gain, and the daylighting considerations of the facade. And I suppose these are three areas that are very important, but in a lot of ways work against each other. The more glazing I have, the poorer my thermal performance in my envelope is, but the better my daylighting. You know, so these are, it's very difficult to find the optimal figure there and the balance around that. And that sweet spot between those three considerations is where Fenestra Pro operates. So it looks at these early stage passive design considerations of the facade to try and find the best solution, or the optimal design solution. So let's jump back into Fenestra Pro. I just see someone making the point that they can't hear any sound. I just want to make sure that everyone else can while we're there. But I'll jump into a conceptual mass, which could be created in Revit, could come from a format mass, etc. And at this stage, this is so early. We're looking at form of the building. We're exploring different options around that, and we haven't really even got to glass to wall ratio. We have no idea on the considerations on the glazing solutions, the glass to wall ratio of the entire building, or how that glass to wall, how that glazing is broken up on different orientations. So if I open Fenestra Pro and start looking at my facade manager, as I said, my dashboard is populating, but I have no glazing yet. So it's showing an overall U value which is quite low based on some of the these considerations. There's no glass to wall, there's no percentage glazing, there's no heat gains internally, there's no daylighting internally, and that's what we need to start looking at. So Fenestra Pro uses the form factor of the building. In other words, that ratio or the relationship between the volume of the building and the surface area of the envelope. In other words, as I start setting the thermal performance of my roof and floor, it affects it looks at the overall performance value of the entire envelope and strips out the elemental performance of my roof and floor to give me just my facade performance. In other words, poorly performing roof and floor, my facade has to improve accordingly. High performance roof and floor, my facade can loosen up somewhat. And it's that kind of balanced approach that, again, the optimal solution that Fenestra Pro is seeking. Likewise, as I start setting the thermal performance for my glazing and my wall, it takes it from the facade performance to give me the glass to wall ratio. Poorly performing glazing, less glazing allowed. High performance glazing, I can figure out how to use more glass, So if I have a figure, arbitrarily arrived at, say, 44%, I can apply that to my mass, and it just, whacks onto the mass in a very arbitrary notional manner of 44% on every facade equally, and it starts giving me solar loads. In other words, heat gains per unit floor area internally. So quite high to the south, quite low to the north, as you will imagine, with equal glazing throughout. However, I could start looking at codes, and I could start populating on my own codes. We have a couple here just, for demo purposes, put in. Let's say we'll use this one here. We can see that a number of these figures go red. In other words, they're non-compliant with the selected standard. So the user can create and save these based on whatever standards that you're using, quite regularly, whether it be, local standards or ASHRAE or UK Part L or whatever that may be. So a number of these figures have gone red, in other words, non-compliant. If I drag and improve my roof, it will go from red to black. In other words, it's now compliant with that standard. Or I could hit set and it will jump to those particular values throughout. So I could apply that code, that figure in this scenario, ASHRAE limits to 40% based on heat gains, etc. So that's got to be considered, but it's a very good tool with regards to understanding the implications of codes on the thermal performance of the envelope, and then off the back of that, how does that affect my glass to wall ratio, and in fact, how can I value engineer my glazing and the thermal performance of different elements of the skin to achieve those codes. This applied 45% glazing equally on every surface, on every facade, and that's fine, and we can start getting an understanding of those decisions around that, but it doesn't make for great architecture, right? And I might have a couple of key facades to a streetscape or to the front elevation, front facades that I may want to address a little further. So, for example, we're looking at it, the overall building here, first of all, and we can apply default types of glazing. Wouldn't be unusual for a quite a simple 3-story building here to have a typical type of glass that's used throughout. Maybe we might have something a little bit more specialist on one particular facade, but let's say we can apply this one throughout. I'll apply that and I'll recalculate, and all my solar heat gains reduce somewhat. Okay, so it's a better performing glass from a solar heat gain point of view. I'll choose this facade though, and I'll say, well, I don't want 44% on this particular facade. It's key elevation. For whatever reason, I want 65%. So I can apply that, and I'll recalculate, and it's applying 65% on all my facades now. My solar heat gains have increased. If I go back to my overall building, I can see it's 65 glass to wall ratio. 65% glass to wall ratio on this facade. Everywhere else is reduced equally. Okay, so we're still equal everywhere else, but obviously we've quite high heat gains on this facade. So I'm going to have to address it somewhat a little bit further. So I can do that a couple of ways. I can reduce the amount of glazing. I don't want to do that. I could change the type of glass. Let's do that for argument's sake. Let's just choose something like this. Quite randomly, it's reduced from 66 to 36 watts per square meter. I can apply a canopy, and you'll see there as I start dragging this out, my canopy starts populating onto the building. That will have quite a big effect on it. Let me actually reduce that somewhat. Let's say even 3 feet deep. The effects of that. I can apply a frit, so a transfer to the glazing. Percentage transparency against percentage coverage over the glazed opening. So, a very good way, effective way of managing heat gains, not unusual in an office scenario or a retail unit, for example. So, with those few just very quick management tools of my solar heat gains, I've reduced that uncomfortable solar heat gain internally to a much more comfortable value on an annual average. I could also drill down into individual surfaces. So say, for example, this surface here is a retail unit, and I want no frit, for example. Let's just take that away. So I'll recalculate that, and I want no canopy, and I want different types of glass. So we can just play around with that, and as you can see, it's treating that one individually. And if I go back to my overall facade, it gets very granular around different surfaces and different facades. These are annual averages. We can drill down into monthlies a little bit as we work through it. I can then disable that facade, so anything I change from here on out won't affect this particular facade. And what I mean by that is I can auto distribute on my around each facade. So let's say this one to the north, I want no glazing. I'll recalculate that, and I'll disable that, and say no glazing to this one as well. Calculate that. So let's go back to our overall building, and we'll see that we've 65% on the south, 0% to my two northern facades, and those 3 facades are locked. So we're still equal everywhere else. We've still got 44% on an overall basis to the entire building, but a number of these facades are locked. So what I can do at that stage is I can auto distribute. In other words, apart from the 3 facades that are locked, it will equalize the heat gains on all the other facades. So what we'll get is differing glass to wall ratios. So, on my west, I've got 66%. On my south, I've got 50%. On my east, so it very much optimizes that geometric design of the glazing solution. So that's the conceptual massing in Revit. But obviously, typically offices and firms get out, if they even use the massing tools, they get out of that quite quickly, into a much more detailed model. So we will, we can take that and we can start working it up into a model somewhat a little bit more like this. Still early stage, but we at this stage have more, let's say, traditional Revit families as we know them. So we have a curtain wall system with properties. It's a family that's populated with information. We have wall systems and roof systems, etc. So Fenestra Pro can also obviously support these kind of models. Some differences around the conceptual massing. First of all, the difference being, in the Performance Manager is that all of these figures now are being read from the model. So in other words, the U value or R value, if you're looking at an imperial model of my roof, is reading from the family as being 0.25 watts per square meter Kelvin. The U value for my glazing is being read from the model as being this, and all of those figures are being populated by your Revit model. The only one that's not, and it's showing it, showing a slight warning, showing that there's no U value or R value being assigned to that ground floor, is this one here. So you can start, manipulating that to affect change. Again, based on my Revit model and the model that I've created and developed and populated, I can see is my percentage glazing to the model exceeding that allowable glazing or not, So in other words, I might have to play around with the thermal performance of the glazing or the solid panels or the wall systems, etc. So you can very much get a very early stage understanding of, am I complying with codes or not? I suppose the bigger difference between the conceptual massing and the detailed model is in Finestro Pro is the facade manager. So we touched on this quite briefly earlier on, whereby we can choose different facades now and they drop into our facade manager. So we can do that a couple of ways. We can choose from a tree, and with each of those facades, which is automatically numbered by Revit as you're developing your model. And then Revit will also automatically create different surfaces representing the internal spaces or, whatever spaces to each of those facades. So we could choose it from that. So I could select, say, facade number 7, and I'll see all the different parts of that facade, the different surfaces being curtain walls. And within that curtain wall, then I'll see the type of glazing, the type of solid panels, etc. But I could also change the name of that. So I could right-click that and rename it. So call it East, Southern Elevation 001 or whatever that may be. I could also rename any of these surfaces. And I could group them together. So I could say I want facade number 7, facade number 12, and facade number 4, for argument's sake, to be called key facades. And then every time I select that group, all of those facades will select. I could also select them in different ways. So rather than facade by facade, I can choose by orientation. So I could select, rather than something to the south, I could select everything to my west. So it chooses each of those curtain assemblies here and the opaque wall systems in between. But I could also filter down somewhat. So I could say, everything to the west greater than 50% glazed, or everything to the west to the ground floor, or whatever that may be. So there's loads of different ways of managing, filtering, slicing and dicing those facades and those surfaces to select and call them up later. Or we can select off the model just by clicking the assembly, or we could also select from our charting, so if we can just select number 7 there, it drops in accordingly, Well, it usually does. There we go. So the next thing here we can see is that within that curtain wall, we can see that there's quite, domestic style, I suppose, Pilkington double glazed units as the glaze panel element of that curtain wall system. If I double click that, it calls up the type properties of that particular system panel, and I can do a couple of things with it. If you have some custom properties already populated as part of that glazing, you can map it with regards to thermal performance or the solar heat gain coefficient. Or you could also select from a list in Revit. So some okay stuff, some pretty out of date, types of glazing. For some reason, Pilkington's is the only manufacturer in there. But if we choose, for example, something a lot better performing, this low E triple glazing, and we apply that, that will do two things. First of all, it will update and repopulate my charting, my dashboard, and then it drops it. It updates my facade manager and shows it. Each of those glaze systems as the new type of glazing. Now, as I said, that list is a little bit out of date. It's difficult to change. It's difficult to add to, and that's Fenestra Pro Link. That's what that basically does. So it populates that list with much more up-to-date manufacturers' data, and gives us the ability to search and manage or iterate through that in a much more meaningful way. So I'm not going to touch on Link today. I think we might follow that up as a later webinar, or indeed, if you guys are interested at any later stage, please get in touch with the guys in Microsol and we'll set something up, on a more kind of one-on-one basis. A couple other things I want to show as part of this detailed modeling. I touched on snapshots. So at any point, we can export all our information to Excel. I mentioned earlier that these figures here with regards to solar loads are annual averages. Okay, so they're going to be much higher in the summer and much lower in the winter, or maybe vice versa based on your shading devices and orientation, etc. But annual averages, as I said, we can drill down a little bit further by exporting to Excel. So the first time I hit this Excel snapshot icon, it will prompt me to create or to create a new Excel spreadsheet on the project directory or save locally or wherever that may be. Every time I hit that button thereafter in this project, it will create a new iteration within that same Excel sheet. So effectively what I'm talking about getting is a sheet like this that will be populated with some basic project information, the areas, the address, the project name, etc. It will automatically populate this table for each snapshot that I've taken. And it will also automatically create a new tab in Excel. So option A, I'm happy with my glazing distribution and the aesthetic of the building, but I can see throughout the year and across most of the surfaces are got quite a high level of heat gain internally. So I've changed the glazing type and I've taken another snapshot. I've changed the glazing again and I've taken another snapshot. So very quickly you can visually see the implications of those decisions or those modifications as you work, but also you've got the data to back that up, both surface by surface, facade by facade. We've got some heat gain and orientation information, daylight performance, and then a kind of cool quantified table showing facade by facade, the area of glazing on that facade and the type of glazing it is. So very quickly you've got something, for your own design team, for your cost consultant, for your mechanical engineer, whoever that may be, So anything else I want to show you here? That just gives a good overview on the detailed elements of Fenestra Pro. The last thing I want to touch on is basically the ability to generate glazing. So what we're trying to do at Fenestra Pro is give the designer the ability to drive the model based on performance requirements, but also give the aesthetic. We're designers. We need to see that previewed, or we need to see what it looks like, and we need to make decisions as we're working. So if I go to a third model, oops, sorry, I lost Revit there. If I go to a third model with the same building, but I'm going to take these two facades as being blank, okay? And I might have a different consideration to those facades. Say it's a hospital, and I have a limit to the solar heat gain internally that I need to achieve, or I have a school that I have a daylight performance, or have an ASHRAE building that I have a limit on the glass to wall ratio on that particular facade. So if I choose those two facades, facade 1 and 2, and we can see the breakup of the internal spaces on the energy model, I can add glazing to that. So I can add glazing based on a couple of things. So let's start with percentage glazing. And I want to say, let's say at the outset, let's say 30% glass to wall ratio. I can preview that, and it will, again, just like the conceptual masking, it will drop it in as a very notional strip of glazing. Doesn't look great, but it does give me my 30% glazing, and it shows me the solar loads that I'm going to be achieving on each of those facades. And bear in mind, those facades are different in orientation. So, the glass to wall ratio on one facade is not going to be not going to be the same on the other facade when we're driving towards solar load. But I might say, actually, I have a I have a solar load that I need to achieve of 20 watts per square meter. Let's show that again. And again, a notional opening, a lot smaller. But I might say, well, I have a glazed penetration that I want to achieve. So 1 meter wide by 2 meters high by a sill height of, say, 600 millimeters or 2 feet. Let's equally spread them. And I can preview that again. It shows me that window penetration, populates it in as a preview to achieve as close as Fenestra Pro can get to 20 watts per square meter for each of those different orientations. We can drill down somewhat, and we can, isolate particular areas and say, well, let's say, just for argument's sake, we want a 3 meter wide window there. Let's preview that. And then when we're happy with the entire solution, let's just say, we can create the windows, and it will drop them in as Revit families, with all the inherent properties that we've discussed there. Fenestra Pro updates, my charts update, I can export that information to Excel. I'm hoping that, if you use this, you might get something a little bit more architecturally sound, but just to demo the quick overview of adding glazing and window penetrations or curtain walls based on different considerations than just an aesthetic at an early stage, So let's go back to here. Hopefully that gives you a good overview of the application. I did want to just touch on, how are we doing for time? It's just coming up to 1:15. So I did want to touch on a workflow of format, format mass into Revit, what you can do with it there using Fenestra Pro, and then using Insight 360. So, I can let this play. Harry, I don't know how we were doing for questions there, but if there's any questions, happy to discuss anything now.
Yeah, there was a question that came up specifically. Can you use format models with Fenestra Pro?
Well, you can, yeah. So, this video actually shows it quite effectively. So there's no API for format yet. So we don't have Fenestra Pro for format. However, because format and Revit are built on the same workflow, I suppose the idea is that a mass or a form is created in format, and like Mike in my office did this short video here, that he's created the form, he's doing some exploration, he's applying some glazing, he's looking at the radiation or the heat gains per orientation. He then brings it into Revit, and that's just a straight import. Very quickly. There's no messing around like you might with Rhino or SketchUp. It just brings it into Revit, and then you can use Fenestra Pro on it there. So it's really simple. So that sort of that really intuitive workflow works quite well and lends itself quite well to Fenestra Pro. And a lot of that data, well, actually all of that data that Mike has you populated as part of the format mass comes into Revit, and then Fenestra Pro starts leveraging it.